Good evening and welcome to the Q&A session 19 from the playlist of Wave Optics. The topic is the fringe displacement in the Young's double slit experiment. And based on this topic, I have one question for this session, which is written here on this board. So the question here is, in the Young's double slit experiment, fringes are displaced by a distance x when a glass of refractive index 1.5 is inserted in the path of one of the beams. When this glass is replaced by another glass of same thickness, then the shift of the fringes is equal to 1.5x. So the refractive index of the second glass is, so we have been given here 4 options, and the correct option is to be found out. So in the previous session, that is in the session number 18, we have learned that the additional part difference due to the insertion of a transparent plate in the path of one of the beams is given by the formula, that is delta x is equal to mu minus 1 into t, where t is the thickness of the transparent plate, mu is the refractive index, and if the fringe shift is equal to say y, then delta x is equal to y multiplied by small d divided by capital D, where small d, this is the separation between the two slits in the Young's double slit experiment, and this is the separation between the slits, and capital D is the difference between the screen and the slits. So from this formula I can get the value of the fringe shift, which is equal to delta x into d. Now delta x is equal to mu minus 1 into t. So this fringe shift will be equal to mu minus 1 into t into d, capital D, divided by small d. Now I will be using this formula in order to find the refractive index of this second glass. So in the first case, the fringe shift is equal to x, so x will be equal to this, x is equal to mu minus 1. Mu in the first case, that is the refractive index, is 1.5 minus 1, minus 1, that is mu minus 1, so 1.5 minus 1 is equal to 0.5. The thickness of the glass, and multiplied by the this separation between the screen and the slits, which is equal to capital D, divided by D, where D is the separation between the two slits. So this is the first equation. Now I will be getting another equation by considering the second case, when this glass is replaced by another glass. So in the second case, the fringe shift is equal to 1.5x, and this will be equal to mu minus 1. Mu is the refractive index of the second glass, into t. Now t is the thickness of the second glass. Now here it is written that the thickness of both these two glasses are the same. So if I have taken the thickness in the first case as t, so in the second case it will be t, multiplied by capital D divided by small d. So this is the second equation, and this is the first equation. This one is the first equation. Let us say this is the equation number 1. So if I divide this equation number 1 by 2, then I will be getting 1 divided by 1.5, because this x and x will get cancelled out, and similarly this t and this capital D and D will also get cancelled out. So finally I will be left with 0.5 divided by mu minus 1. So this is, it implies that mu minus 1 will be equal to 1.5 into 0.5. So 1.5 is basically 3 by 2 into 0.5, which is equal to 1 by 2. So this is equal to 3 by 4. Or we can simply say that mu is equal to, mu is the refractive index of the second glass. So this is equal to 0.75 plus 1, that is equal to 1.75. So the refractive index of the second glass is equal to 1.75. So the correct option here is A. So thank you very much for joining this session. In the next session, we will be coming up with a different type of a question based on the same topic, that is fringe displacement. So till then, have a nice day. Bye.